Professor. We are going to go to talk about the efficient power generating portfolio in Brazil, considering cost, emission, and risk, with my main team, Philip Bustos, Andres Ceballos, and myself. Our presentation will have four contents: introduction, methodology, result and discussion, and conclusion. The most important in this page is to assess efficient and Brazilian electric generation mix produced in the DPE 2020. DPE, or Decennial Plan of Generate Energy Expansion. It evaluates estimated cost, risk, and carbon dioxide emission following the mean variance portfolio theory. The efficient frontier is estimated for three dioxide, carbon dioxide scenario prices: no prices, low prices, and high prices. So what is DPE? DPE is the one most important energy planning tools in Brazil. Ministry in Brazil Energy is the planific energy or energy policy. In the electricity generation mix is predominant hydropower with 79%. This is the goal in the Brazil energy planning, the most important. Maintain renewable energy source, minimize the cost of generating portfolio. Two most important questions for this paper is how efficient in terms of cost and risk is DPE. The second was the feasibility of DPE. This is the electricity generation mix. In this, the most hydropower for the 79% of the capacity total. Okay, in this figure, it can be seen evolution of the generation portfolio according to the 2020 DPE in 2010 and 2020. This will increase in the, for example, wind power. This is 0 or 6.70%.
Well, the methodology applied is the mean variance portfolio theory to calculate the efficient frontier for power generation technologies in Brazil. So each portfolio is an electricity generation mix that has associated an average cost plotted along the y-axis and a measure of risk plotted along the x-axis. To derive the average cost of each portfolio, it is performed a probabilistic experiment based on parameters specific to each technology. For example, efficiency factor, price of fuel and raw material, operation and maintenance costs, emission factors, and others. And then this average cost was classified in three scenarios: 0, low, and high carbon dioxide emission cost. Well, the estimated risk depends on the cost structure of each generation technology, and the calculation incorporates the fluctuation of these factors: fuel cost, operation and maintenance cost, risk of investment, and emission cost. And in this table we can see the risk or standard deviation of each electricity generation technology. Also, the matrix correlation, the correlation matrix was calculated, and we can see in this table the most important correlations between fossil fuel prices and between fossil fuel prices and emissions costs.
Now I will present the estimated result from this paper. First, I need to understand any logical restriction. All restriction in this paper is for weight, for technological weight. For example, the first important exception regard is for the nuclear plant, and only with the GPE. In this case, GPE interval is for 1.2% and 0.8% respectively. And second, we need to consider the following restriction regarding to the maximum share that some generation option can reach the generation, in this case, for capacity. This paper is all for the under different CO2 scenario. This scenario are first when the price is zero, when the price is low, and when the price is high. And in this case, for the second restriction, we can see 70% for the large hydro and 3% for small hydro. 3% for the small hydro. And second, 10 for biomass, and the 15 for the one U. All is logic for all that for the positional impact for the security of supply. And finally, the most important, in this case, we need to keep the all weight in new and old plants in this case. In this figure, we can see the actuality GPE for the GPE 2020. For example, in this case, we can see the higher new have the more risk, but the minimum average cost. And in this case, for example, biomass is the most near for the lane, but have the minimum risk, but more average cost. And this is the efficient frontier. We need to learn here. This figure shows the best performance in the both dimension is the mean between A and B. For example, this is the GPE. The reference portfolio is GPE. But for example, I want to move it to the point A. I can minimize the risk, but no is the more option. And if I want to move it to point B, I can minimize the cost average. For example, we need the best performance in both dimensions of variable. In this case, the mean between the A and B. That is the first scenario when the price is zero. The most important here is this table, the risk and average cost, and that date is for the year after. And this table shows the all weight in the portfolio.
Well, in the scenario 2, the most important point is that with an introduction of price of emission cost, the participation of fuel, oil, fossil fuel plants will decrease, and the predominance of renewable sources was increased in the all kind of portfolio.
In this case, the most important is the diversification in the portfolio GPE, because implies risk reduction of around 10%, the portfolio more efficient.
Finally, for the conclusion, we can see the all figure on the all scenario. And finally, we can say in the figure we can show the GPE portfolio is relatively close to the efficient frontier. And all that is, for example, for low price, for high price. For example, when the low CO2 cost is 90, we need the high wind generator, and the other scenario, when the price is high, for the CO2 cost is 90, we need investment in the fossil fuels. When the 12.2%. And this, for finally our presentation, when the introduction of the CO2 cost has a low impact, but that is really significant only in the total cost.